1, 4, 6. Aubrey, which one was yours? 9. Okay. All right, that should be plenty, right, to get a good idea of what's going on here. Oh, do you want the answers? Okay, I'll give you the answers. All right, let's do number 1. And we scribbled out number 9. We're going to do number 10 instead. All right, so here we go. 4K. I'll tell you what. You don't mind if I write an X instead of a K, do you? My K's, I think, might look a little ugly here. So 4X, is that all right? Plus 4. And that. Actually, you know what? I lied. Not on purpose, but let's make it a K. Because I want to substitute X. I always like substituting X, yeah. So I don't want to start off with an X. So it looks like that, minus 5. And then, where are we? 4K plus 4. And then minus 6 equals 0. All right, this substitution is actually a little easier than what we did yesterday, to tell you the truth. Now, we didn't do one exactly like this yesterday, but the substitution is pretty easy. Look, what is this? This looks like a quadratic, doesn't it? It looks like something squared minus 5 times that number minus 6. It kind of looks like x squared minus 5x minus 6, doesn't it? All right, but instead of x, what is this? It's 4k plus 4. So guess what we're going to do? We're going to let what? X equal 4k plus 4. You've done stuff like that in calc, right? Where you substituted things in like that. Yeah, so even in calculus, they use this step. It's a pretty common thing that you do in math, okay? So it's not just with this one particular problem in this one particular class. I mean, throughout math, there's a lot of times you'll be doing this kind of stuff where you'll let x equal something and you'll plug it back in and that kind of thing, all right? So if x is equal to 4k plus 4, I'm going to turn that into an x, so what do I got? I just got x squared, right? Minus 5 what? X minus 6 equals 0. Now that looks a lot easier, doesn't it? Okay, and you should be able to solve for x. We could factor this, can't we? Yep. I always look to see if it factors first, because that's usually a lot easier. Okay, if you look at it and you're like, I'm not really sure if it factors, then what's probably your next way of doing it? Yeah, you could complete the square, or what's probably more of your favorite way? What is it? Yeah, the formula, quadratic formula, okay? But this one does factor real nice. X and x. One's going to be plus, one's going to be minus. Would you agree? Now, it has to multiply to be 6 and add up to be negative, or negative 6, and it has to add up to be negative 5. So what are you going to use? Are you going to use 3 and 2? Yeah, you can't use 3 and 2, because if I use 3 and 2, I can't get a negative 5 if I have a plus or a minus right here. So I have to use 6 and 1, don't I? It's going to be negative 6 and positive 1. When you multiply them together, it's negative 6. When you add them up, it's negative 5. And then you just set these equal to 0. So x plus 1 equals 0, and x minus 6 equals 0. Look, after some time, you should just be able to go from this to the answer, don't you think? Instead of writing x plus 1 equals 0. Yeah? Okay. If not, that's why I write this stuff down, just so you know exactly what we did. So if you solve for x, what's x? Negative 1, and x is what? Positive 6. That's not the answer they gave, is it? Oh, that's right, of course. Haha, it's not our answer. I knew that. I was just testing you to see if... no, I'm only kidding. I just forgot. So we just solved for x, right? We're not trying to solve for x. What are we trying to solve for? We're trying to solve for k. So you're right. We've got to plug it back in. All right, so let's do this. We've got two things here, right? So let x equals 4k plus 1. So what are we going to do? 4k plus 4, not 1. 4k plus 4 equals what? Negative 1. And what else? 4k plus 4 equals what? 6. Right, now we'll get something. Here we go. Subtract 4. This is just basic algebra. And that's negative 5 divided by 4, so negative 5/4. Is that one of my answers? Yep. And then let's do this. Subtract a 4. So watch. Just our head, right? Subtract a 4. That's a 2. Divide by 4. Simplify that. That is 1/2. There you go. That's the answer I read off, isn't it? It wasn't so bad, was it? It's pretty easy substitution, tell you the truth, I think. I think it was pretty easy to see. Look, all this stuff is being squared. This is the same thing as this, isn't it? So I can make them both x, because it's the same thing. What if I had like 3x minus 7 in here? Could I let x equal anything? Not really, because If this is 4k plus 4 and this is 3x minus 7 or whatever, these have to be the same thing. You understand that, don't you? Okay, and every single one of these problems, they do make whatever this x is, they make that x being squared over here. And that's the only way we can do that. All right, let's do another one. Let's do number 4. Is that what you want? All right, let's take a look at number 4. All right, this is where you have that negative exponent. 2m to the negative second plus 7m to the negative first minus 15 equals 0. All right, this is to the negative second. That's not a true quadratic, is it? All right, so what we want is we want this. Actually, let's look. I always look here. I always look at the middle one. This middle one right here, I would like it to be what? Got on? All right, let's get back to this. What would we like this to be? We would like this to be what? 2x squared, right, plus 7x, right? Now, it's not that, is it? But we would like it to be that, so what can we do? We can say let x equal what? That's right, m to the negative first. Exactly right. Do you see that? That's what we always look for. We always look for this middle term. You let x equal that, and then it's a little bit more normal. So watch. 2 what? X squared. Because, look, x is m to the negative first, isn't it? If I square that, what is that? It's m to the negative second, which that is right there, isn't it? Okay? So it's 2x squared plus 7 what? X minus 15 equals 0. All right, now here's one that, I don't know, it may factor, all right? I'm not really sure if it factors nice or not. It might. I don't know if I want to sit there and try a whole bunch of things to see if it factors or not. I don't know. You might give it a shot or two, and if it doesn't, then you can always resort to what? The formula, right, okay? Or you could just do the formula right off the bat, couldn't you? So why don't we just do that? We haven't done the formula in a couple days, so let's do that. So it's negative b, or negative 7, plus or minus, square root, b squared, which is 49, minus 4 times a times c, which is negative 15, over what? 2a, which is 4. All right? So let's simplify this. So it's negative 7 plus or minus, square root. Let's see. 4 times 15, that's what? 60. Times 2 is 120, am I right? So 120 plus 49 is 169, am I right? Okay. Just double check my math. I could have made a mistake somewhere. I think that's right though, isn't it? All right, and let's see, 169, that's 13, isn't it? Square root. All right, so it's negative 7 plus or minus 13 over 4. So we got two things here. We've got negative 7 plus 13 over 4. We have negative 7 minus 13 over 4. What's that? 6 over 4, right? What's 6 over 4? It's 3 over 2, right? Yes? Then right here, negative 7 minus 13 is negative 20 over 4. That reduces to negative 5, and there's your answer right there. Got to plug it back in. It's the second time I did that. Thank you, Aubrey, for keeping me straight. Because that is not what we're trying to solve for. That's what x is, isn't it? But we're not trying to solve for x. We're trying to solve for m. So this is what we're going to do. We're going to use this thing right here. And so let's do it. So x is m to the negative first, or m to the negative first is equal to one of these x's, right? 3 over 2. And I'll tell you what, since we have got everything in the same color, let's just change colors here. Is that all right? Separates it a little bit. And then m to the negative first is also equal to what else? Negative 5. Now, what's the deal with this? This is m to the negative first. Or you could think of it as 1 over m. But what do I want to do? I want to get rid of this, don't I? So you can think of it a couple ways. You could think of it as, you could take this to the negative first, couldn't you? So what happens? If I have m to the negative first, what's that? It's m to the what? To the first, right. Negative 1 times negative 1 is positive 1, right? So I could take this to the negative first, right? Or you could think of it like this. M to the negative first is 1 over m equals 3 over 2. I don't want to solve for 1 over m. I want to solve for what? M. So what do? Well, take the reciprocal of this, right? Yeah, if I take the reciprocal, if I flip this, then what do I do with this? I flip that. That's an easy way to look at it too, isn't it? So what's m equal to? 2/3. Because 3 over 2 to the negative first basically means you take the inverse of it. Because something to the negative first means you take the inverse of that. Does that make any sense? All right, so that's what we do. So when it's to the negative first, all we do is we take that number and we just flip it. So that is one of our answers. Am I right? What about this? What do we do with that? Flip this one. So you flip this one, and it makes it a, excuse me, m to the first. We got to flip this one. Now we're not just changing the sign, are we? That's not what we're doing. What are we doing? It's negative 5 over 1, so what's that going to be? Negative 1/5. Okay? So there's your answer right there. 2/3 and negative 1/5. And that is the answer that they want. So that to the negative first thing, it looks a little confusing at first, but that's not so bad, is it? So if I want to just get this to be an m, I just flip it. Because technically, m to the negative first is 1 over m. How do I get that to be an m? I just flip it. But if I flip one side, remember, whatever I do to one side, I can always do to the other side, right? Or I need to do to the other side. So if I flip this to get this to become an m, I got to flip this one, right? Whatever you do to the left side, you got to do the right side. So I flip this. So if I flip it, I get 2/3. If I flip negative 5, I get negative 1 over 5. We good? All right. Let's do another one. Let's see where we're at. 6. Okay, good. And I think that should be it. That's pretty much one of each, I think. Would you agree? Because when have one with a negative exponent, this one's to the 4th. The other one was like some, crazy polynomial. Excuse me. All right, number 6. Oh, I'm tired of this color. What haven't we used? Have we used blue today? Let's use that now. So I got 5y to the 4th, and then minus 21y squared, and then plus 18 equals 0. All right. Now again, it kind of looks like we want it to, but not quite, because what do I want this to be? I want this to be 5x squared, don't I? And I want this to be 21x. Would you agree? So really, what do I want to do? I want to make that into an x. So what do we say? We say let what? X equal y squared. Yeah? Look at this. Does that work? Because if x is y squared, what is x squared? Well, x squared is the same as y squared squared, right? Which is y to the 4th. So that is x squared, isn't it? So let's write it. Let's write it 5x squared minus 21x plus 18 equals 0. Now I can solve for this, do my substitution, right? Don't let me forget, because I've forgotten twice today. So make sure you do your substitution at the end. Make sense? I don't know, is this an easy one to factor or not? Probably not. So what are we going to use? The formula. Okay, you could complete the square, but we did that yesterday, right? And you saw it was probably a little bit more of a hassle to complete the square than use the formula. So let's use the formula. So negative b. Well, b is negative 21, so negative b is what? It's positive 21, right? Plus or minus square root b squared. I don't know. Who's got a calculator? I should know that in my head, but I don't. What's 21 squared? It's like 4 something. 441? Okay. So that's 441 minus 4 times a, which is 5, times c, which is 18, over 2a, 2 times 5, which is 10. Now it's just a matter of simplifying this thing. Alright, so it's 21 plus or minus square root. Somebody do this for me. What's 20 times 180 is, what's that, 360? Is that right? So 441. I don't want the whole answer. I want 441 minus 360. What's that? That's a 1, and that's an 8. 81, is that right? Did I do that right or not? Somebody do that on a calculator. I did? Okay. And that's over, what? 10, right? Well, that works out nice. I like the square root of 81, don't you? So I've got 21 plus or minus. The square root of 81 is just 9. Y'all done now? Yes. Okay, thanks. Over 10. Make sense? So let's do it. It's two things, right? That's why you got to make sure it's plus or minus, and you put that on there. So it's 21 plus 9 over 10, and it's 21 minus 9 over 10. Yep. Okay, it's in the pile. Yep. So what do we got? We got 30 over 10, which is 3. So x is 3. And we got 21 minus 9, which is what?
Do I get the multi-purpose?
12. Yes. 12, right? Over 10, and reduce that to, what's that, 6/5? So x is 6/5. Do we circle that? No, we don't. I remembered, yay. What did we say? X was equal to y squared, correct? So watch what I'm going to do. I'm going to say y squared is equal to each of these. So y squared is equal to 3, and y squared is also equal to 6/5. That's our substitution, right? So now we solve for y. So take the square root of both sides. Don't forget your plus or minus. So that's plus or minus square root of 3. So that's 2 answers. Let's do this. Take the square root of this. It's a fraction, though. It's a little more difficult than just saying square root of 3. So what is it? It's the square root of 6 over the square root of 5. Remember what we have to do? We can't leave the square root of 5 in the denominator. So we multiply top and bottom by the square root of 5. And what do you get? Square root of what? 30 over 5. And that's what y is. Plus or minus. Don't forget that. So there's your answers right there. And is that how they wrote it? No. They wrote the square root of 6 over 5. What did I do? Because square root of 30, 6 times 5, 2, 3, 5, that doesn't simplify, does it? So why did they write square root of 6 over 5? Did I mess up somewhere, or did they mess up? Did you see anything I did wrong? Is 6/5, is that right? Is that 12? That is 12, right? Yeah. And then 2 goes in that 6 and 5 times, 6 over 5. 6 over 5, square root of 6, square root of 5. Square root of 5, square root of 5, that's square root of 30 over 5. I think they're wrong. We'll find out. I am challenging them. I challenge you. Book answer. Well, anyway, I think I did it right. Do you see anything I did wrong? I don't know. I think we're good. It always doubts me when I get something different, but you know, it happens from time to time. That was kind of fun, right? Finding, I think it's the wrong answer. We'll see. Alright, so the answer that they have in the book is, let's see, what, square root of 6 over 5, is that right? Yeah. So plus or minus square root of 6 over 5. So that's the book answer. And that's my answer. I kind of like my answer, don't you? Alright. Okay, just put it on the pile. Alright, that's it. Do you want to do number 10? Just to, let's do number 10 for fun, okay?
Did we do one with a fraction?
We did not. Like number 7 and 8. You want to do one of those? Or 3? 3, 7, 8 all have fractions as exponents? Yeah, let's do one of those. That'd be fun. Which one? 8? Okay. Kind of answer. Alright. Let's see. 6x to the 2/5 plus 5x to the 1/5 plus 1 equals 0. Alright, so what are we going to do? Let what? Well, they use x already right here, don't they? So let's use another. Let's say a. Is that alright? Let a equal what? X to the 1/5. Is that alright? And so what are we going to do? Now watch. If I square x to the 1/5, what do I get? I get x to the 2/5, right? And that's what that is right here, isn't it? So this is really what? 6a squared plus 5 what? A plus 1 equals 0. I don't know. Does this factor? Let's just try something. It doesn't? Alright. Well, it might. I don't know if it does or not. But I bet you it does. But you like the formula, right? So let's do that. So negative b plus or minus square root b squared 25 minus 4ac over 2a, which is 12, So it's negative 5. Sorry for my writing, just writing too fast here. So what's that? 24. 25 minus 24. Well, that's easy. That's a 1. And that's over 12. So it's negative 5 plus or minus 1 over 12. So I've got negative 5 plus 1 over 12, and I've got negative 5 minus 1 over 12. That's negative 4 over 12. Negative 4 over 12 is what? Negative 1/3, correct? So that's what A is, correct? And then over here, that's negative 6 over 12, which is negative 1/2. So A is negative 1/3 and A is negative 1/2. Put it over here, so watch what we get. We get let's do it like this. X to the 1/5 is equal to A, right? So this is one of the A's, so it's negative 1/3. And then I have X to the 1/5 is equal to negative 1/2. Okay, here's the deal with the fraction. So far, that fraction hasn't really bothered us at all, has it? Right, all I did was say let A equal X to 1/5, and then I don't even have to worry about that exponent until all the way down here at the end. What do I do to get rid of a 1/5 exponent? Not multiply it. Multiplying it by 5 is not going to get rid of that exponent. Taking it to the 5th power, though, will get rid of that exponent, won't it? Because 1/5, what do we do with an exponent taken to another power? We multiply them together. 1/5 times 5 is 1, isn't it? Now, I can't just do that to this side. What do I have to do? I got to come over here and do that to this side as well. Make sense? Same thing here. Take this to the 5th, take this to the 5th. And let's go back to my color. Which color did I use? That one or that one? That one, I think. So look what we have. This is negative, what is that, 1/3, is that right? Yeah. So it's just going to be negative 1 over 3 to the 5th. Well, let's see. 3 squared is 9. 3 to the 4th is 81. So 81 times 3 is 243, right? There you go. That's one of your answers. Okay. And then negative 1/5, that's 2 to the 5th is 32, so that's negative 1 over 32. There's your answers right there. So really, having that as an exponent really didn't bother me that much, did it? You? Now, all you had to do is know how to get rid of that exponent, though. You take it to the 5th power, and that way you multiply them together, they cancel each other out, but you got to do the same thing to the other side as well, don't you? We good with that? All right. All right, well, that's all we have time for. Look at that. Perfect timing. And I didn't get to go over the next lesson. I guess I'll have to do that tomorrow, okay? So we'll go over part C tomorrow, and that'll be it for 2-6. We'll probably take a quiz early next week. All right? See ya.